One of the simplest and least expensive things that can be done for trees may also be one of the most effective. Applying a 2 to 4 inch, 5 to 10 centimeter layer of organic mulch such as wood chips or shredded bark over the root system of a tree can enhance root growth, moderate soil temperatures, maintain moisture, and reduce competition from weeds and grass. The mulched area should extend as far out from the tree as practical for the landscape site. When it comes to mulch, deeper is not better, and piling it up against the trunk can lead to disease problems. Soil compaction and grade increases deplete the oxygen supply to tree roots. If soil aeration can be improved, root growth and water uptake can be enhanced. Vertical mulching and radial trenching are techniques that have been used to improve conditions for root growth. It is important to note, though, that care should be taken when applying any treatment to construction-impacted trees. Excavating soil may damage roots, even when the goal is to improve conditions for root growth. The arborist might consider postponing soil remediation treatments to allow construction-damaged trees to recover somewhat. Vertical mulching, one of the methods used for root zone aeration, involves making holes in the ground with a drill or an air tool. The holes may be filled with organic material such as compost or other materials that could improve aeration. Research has shown that this treatment has a limited effect, possibly because only a small percentage of the root zone is affected. Another method is radial trenching. Trenches are made in a radial pattern throughout the root zone and should extend at least as far as the drip line. Then, the trenches are backfilled with native soil and compost. Sometimes other amendments are added as well. Use of an air excavator has proven effective for soil aeration and radial trenching. In radial trenching, these devices cause much less root injury than mechanical excavation equipment. For soil aeration, an air excavator can be used to reduce compaction, remove excess fill soil, and improve soil conditions. Soil additives, such as organic matter and inoculants, can be incorporated into the root zone prior to mulching the area. Most experts recommend that trees not be fertilized the first year after construction damage because water and mineral uptake may be reduced due to root damage. It is a common misconception that applying fertilizer gives a stressed tree a much-needed boost. Fertilization should be based on deficiencies shown by soil and/or foliar analysis. If fertilizer is applied, however, slowly soluble mineral sources should be used to minimize the potential for root injury, and application rates should be kept low until the root system has had time to adjust. Despite everyone's best efforts, some trees may never recover from the stresses caused by land development and construction activities. If a tree dies as a result of root damage, it may require immediate removal. It is possible for trees to have a healthy appearance after construction while having extensive root rot. Arborists must inspect and monitor trees affected by construction to evaluate changes in health and structural condition. Look for changes in drainage patterns, soil condition, and sun and wind exposure. Watch for lean, cracks, and indicators of internal decay such as cavity nesting birds, carpenter ants, beehives, oozing, and mushroom-like structures growing on the trunk, root collar, or along the major roots. Stressed trees are more prone to attack by certain pests and should be inspected for signs and symptoms of insects and disease. Arborists commonly have 5 tasks during the construction phase. 1. Enforce the Tree Protection Zone, TPZ. Maintenance of the TPZ may be the most significant activity associated with the post-design phase. Space is often at a premium on construction sites, and the open areas defined by the TPZ are attractive locations for all sorts of activities. 2. Assist with changes in the field. Few projects proceed without changes in the field. This occurs for a variety of reasons. For example, plans and field situations may not match, or an item may have escaped notice or was not discovered until construction. The arborist must participate in the decisions when conditions or plans change. 3. Monitor injury to trees and provide corrective action. Despite best efforts, damage to trees sometimes occurs. Plans and changes may require work within the TPZ. The arborist must be prepared to provide management options where damage has occurred, be it pruning, irrigation, or other treatment. 4. Communicate with the project superintendent. One of the most critical factors in the success of a tree preservation project is the commitment of the project superintendent. The arborist must help him or her understand the need for tree protection while acknowledging the range of demands and challenges placed on the superintendent to complete the project. 5. Facilitate completion of the project. Once the project has been approved by the public agency, consultants and arborists should be assisting in its completion in a timely manner. While trees preserved on construction sites provide important environmental, economic, and aesthetic benefits, construction damage is a common cause of tree death and decline in urban areas. An arborist can help decide which trees are better suited for protection and can work with the builder to protect trees throughout each phase of construction. Understanding how to minimize construction injury is based on knowledge of factors that affect tree health and structural stability, as well as understanding construction practices. Construction equipment can permanently injure the above-ground portion of a tree by breaking branches, tearing bark, and wounding the trunk. Often, the most serious damage to trees caused by construction is underground. Excavation, trenching, and grade changes may remove a large percentage of the root system. Cutting one major root can cause the loss of 10 to 25% of the root system. Trees may show decline symptoms within a few months, or the symptoms may not appear for a few years. Soil compaction can be devastating to trees because it reduces pore space between soil particles, decreases oxygen availability to roots, and creates an accumulation of carbon dioxide, which may diminish root growth and the ability to absorb water and minerals. Heavy equipment compacts and prepares the soil to increase stability and minimize movement that would damage a structure. These compacted areas must remain far enough from preserved trees to avoid damage to their root systems. If tree preservation is to be successful, trees must be considered in each phase of the development process: planning, design, grading, construction, and maintenance. The construction process involves events that require arborists to understand engineering terminology and procedures that occur above and below ground, including 1. Site clearing and demolition. 2. Rough grading. 3. Installation of sewer, water, and utilities. 4. Grading for finish pads and roads. 5. Construction and installation of utilities and structures. 6. Fine grading and installation of landscapes. The arborist should evaluate the condition of each tree and its suitability for preservation, and work with the builder and developers to determine which trees to preserve and which to remove. The decision must consider the species, size and maturity, location, and condition of the trees. The arborist should prepare a plan that details the location of trees and other features in relation to buildings, roads, and infrastructure, showing protection zones and details of all mitigation and preservation measures for the project. Design plans or construction procedures can be modified to better accommodate trees. Examples include bridging over the roots to replace conventional walkways or tunneling under the root system instead of trenching for utility installation. Measures intended to protect trees must be written into construction specifications. Each subcontractor must understand the purpose of the barriers, limitations, and specified work zones. It is a good idea to post signs as a reminder and to build fines and penalties for violations into the specifications. The single most important action at the start of the construction process is to set up a tree protection zone, TPZ, around each tree that is to remain. The TPZ is the area in which no grading, excavation, or construction activity is to occur. Allow only one access route on and off the property, and limit areas for storage and all work related to construction to areas away from protected trees. Temporary mulching within the TPZ area can protect the soil surface and reduce compaction. The arborist should visit the site at least once a week and take photos at every stage of construction in case violation of the specifications occurs. The ability to restore trees damaged by construction is very limited, which is why the emphasis is placed on protection. In the final stages, careful planning with landscape designers is just as important as avoiding tree damage during construction. Plan to continue monitoring the health, structure, and overall vitality of preserved trees. Grade changes can be devastating to trees, even if the change is not severe. A tree's ability to survive depends on the amount of root system that will remain, the tree's species tolerance to root loss, the degree to which the grade is lowered, the soil conditions, and whether irrigation will be applied. If the grade is lowered completely around a tree island can be constructed. The greater the percentage of root system that remains at the original grade, the greater the chance of tree survival. While trees preserved on construction sites provide important construction equipment can permanently soil compaction can be devastating to trees. If tree preservation, the arborist should evaluate the condition of design plans or construct the single most important action. The arborist should visit the site. Grade changes can be Trees can greatly enhance a property's environmental, aesthetic, and economic values. When a future development site has existing trees,